Okay guys, so here's another example of the last video. So if you're good with the last video, this one doesn't talk about anything new. It's just a practice. If you want to go through another one with me, continue to watch. So here's another example of how we're going to use these special triangles. It says triangle JKL is a 30, 60, 90 right triangle with side length LK equaling 4. So I labeled that. And the measure of angle J is 30 degrees, so J is 30. Again, it says, what are the 6 trig ratios for angle J with the measure theta? So that's, again, important. Here's the angle I'm revolving everything around. So I can now identify, here's my hypotenuse. The angle across from my theta is my opposite side. And the side next to the angle is my adjacent side, okay? Knowing that x equals 4, this side length has the measure, what do we think? Has the measure 4 square root 3. Knowing that x is 4, the length of the hypotenuse, what do we think? 2 times 4? It's going to be 8. I have a little 8 somewhere. There we go. Okay, it's going to be 8. I'm going to use that. I know those 3 sides are those 3 side lengths, and now I can write my 6 trig ratios. Okay, so sine of theta, I know sine, so katoa, opposite over hypotenuse. 4 over 8 simplifies to 1/2. Now I can do cosecant, right? It's the reciprocal of sine, so the reciprocal of 1 over 2 is 2. Right? Or I could flip 8 over 4 and I'll get 2. Cosine, the cosine is adjacent over hypotenuse, so I'm going to get 4 square root 3 over 8. And then I can simplify the 4 over 8 and I'm going to get 1/2, right? So I'll get 1 square root 3 over 2. I could use secant. So secant, it's the reciprocal. So if I take the reciprocal of this right here, it doesn't matter which one, if I do the reciprocal of 8 over 4 square root 3, I'm going to then get 2 over square root 3 because 8 over 4 gives me 2. And then I have to rationalize it. Guys, remember this right here. We need to get that square root out of the denominator. To fix it, we multiply the numerator and the denominator by that square root. Okay, so if we come back here, my square root here is square root of 3. So I'm going to multiply both the numerator and denominator by square root 3. My numerator is going to end up being 2 square root 3. My denominator would really be square root 3 times the square root of 3 gives me square root of 9. Square root of 9 I know is 3. Okay, and there I have my secant function. My secant ratio. Tangent is opposite, which is 4 over adjacent, 4 square root 3. I have to simplify it. So the 4 over 4 will simplify to 1 over square root 3. And then I have to rationalize it. Multiply both sides by the square root of 3, and we'll be left with square root 3 over 3. No more radical in my denominator. That's what we wanted. Bad here, radical in the denominator. Good here, no radical in the denominator. And then if I go back here to take the reciprocal, I'm going to get 4 square root 3 over 4. 4's cancel, and I'll be left with square root of 3. So guys, really, this is the same exact example back to the very first one we did where we wrote these 6 trig ratios, but we just started a little bit differently by creating this triangle instead of being given this triangle. Okay, awesome job, guys. You'll try some practice now. Thank you.